Hello guys, welcome to Hardcoder. Today we are going to see the Leetcode problem number 49 group anagrams. Let's get into the question. Leetcode 49 group anagrams. The problem statement is given an array of strings strs, group the anagrams together. You can return the answer in any order. So an anagram is a word or phrase formed by rearranging the letters of different words or phrase, typically using all original letters exactly once. So let's get into the approach. So before moving on to approach, let's define the problem. So what will be the input? The input is a string array strs, and the output should be group of anagrams. So it's a list of list of strings. So this is the output. So they have mentioned that there will be only lowercase characters in each string. Lowercase letters. This is the point to be noted, and that's it. So let's get into the approach. So how to approach this problem? So the anagram as a property. So firstly we have to know about what is anagram. Anagram is nothing but any words. Let's consider word 1 and word 2. So two words can form an anagram group if both the words contain the same size and the same characters. So the count of each character of word one will be equal to the count of each character of word two. So let's see an example. So the word eat and tea. So let's consider the two words word tea and eat. So in this we can see E has frequency of 1, A has frequency of 1, and T has frequency of 1. So let's consider the second word. In second word, E has frequency of 1 and A has frequency of 1, that is EA, and T has frequency of 1. Yeah. So both the words, that is eat and tea, have same number of characters frequencies. So we can group them into a single anagram group. So this is the condition for anagrammic words or phrase. So this is all about anagram. So in anagram, you can clearly see each word will have same number of frequency of each character. So eat and tea. So how can we find a pattern in them? So the pattern in them is if we sort both the words. So after sorting, the word will become AET, and this two it will become AET. So both the sorted words can be are always equal. So are always equal. So this condition will be met only if the words are in anagrammic group, in same anagrammic group. So when we consider the word tan, and we'll check whether tan, the string word tan belongs to this group or not. So when we sort this, it will be A N T, and so the condition required for to form this group will be AET, but it is ANT. So it will be forming a special group. So it will be a different group ANT. So this is the core logic which we are going to apply in this problem. So okay, all set. uh, how are you going to approach this problem? Uh, firstly we'll find the uh, each key, that is the main key, which will be the sorted form of a word, and find which are all the words that fit into the group. So firstly we'll find the sorted string for each string. So we'll find sorted step for each strs. So after finding this is the first step, and after finding this, we'll have a mapped and store a sorted string and the group of words which have the same sorted strings. The sorted string will be a key, and the words in strs will fit into the sorted str. So this is the logic. So let's walk through the test case number one. So in test case one, so this is 0. We'll index them 0, 1, 2, 3, 4, 5. So we need to sort them up. So we'll create a new array which will be, let's name it as encode array. Encodes, encodes, and we'll encode the first. We will encode the each string. So first string will be AET, and we'll sort the second word. It will be AET, and we'll sort the third word, which will be ANT and AET. The fourth word will be fourth index will be ANT, and fifth would be ABT. So firstly we'll form the encodes of each string. So after finding this, what we're going to do is we'll create a map which will store the word. So firstly we'll iterate to the map. So firstly the map will be empty, right? So map will contain nothing. It will be empty. So firstly uh, we'll go to the first word. So the first word is AET. So there is no entry with AET. So we'll give entry as AET. So it's this every cell or string in the encoded array. So AET will store the corresponding index words, that is the index in strs given array. So it will be stored. So after this we'll move on to first index. So it is also AET. So we'll find whether the key AET is present in the map. Yeah, it is present. So we'll store the TEA. So we'll store the TEA, that is T. That is the first index. So we'll move on to second index. So second index encoded word is ANT. So we'll check whether the word ANT occurs in the map or not. So it is not occurring. So we'll create a new map, new list with the ANT as key. So in ANT, we'll store the corresponding word, which is AET. Sorry, which is tan. So we'll store tan here, and we'll move to next index. Next index encoded word is AET. So AET is already present. So we'll just add the corresponding word in the third index to AET group. So that is 8. So we move on to next word. the encoded word is and, so we'll check whether the word a and t is present, so it's present as key in the map, so we'll store the corresponding str to the map. So we have stored, and we'll move on to next word. So next word is abt. We'll check whether the map has contains word abt or not. It doesn't contain, so we'll store abt, and we'll store the corresponding word to the key, that is bat. Yeah, we have completed the iteration. So the final answer will be each group will create a, finally after iterating over every word, we'll create a list of groups. So list of group which will be having list of strings. So let's call it as answer, and here we will be storing each group. So first we will store this group, this group, and this group, and finally return the answer. So this is pretty simple, and the time will it will take to, will be less, but the space will be it will be there consuming more space. So how to optimize the space? We can optimize by using, so consider the case when the given word in strs is a b a. So in this case, so let's call it as strs. So consider the only the given word is only this, so it says that too. So given also, so we need to group. So firstly, what will be the first step? So let's consider the second test case. So what will be the first step? First step will be to find the create the encode array and store the encode values, right? So it will be a 4 years followed by b and z. So we are repeating the word a, I mean the character a 4 times. So if it the in the question they have mentioned that the word's length will be 100. So what happens if we have 100 a? So we'll continue to have the a again and again. So instead of this, how can we optimize this? So we can just take this character and upon the number of occurrences of the current character, so a 4, and for b we'll store b1, for z we'll store z1. So this will be consuming less space than storing this type of encoding. So this is what we are going to do to optimize our approach which we have found before. So how are we going to calculate the frequency? So we'll be using a integer array which will have a size of 26, and we'll iterate over each character and increment the character index corresponding to it, corresponding to the character. So this is the logic we are going to do. So after the first step, that is we have calculated the encodes array. So for secondly we'll create a map and store the values, right? So firstly the encoded it will be 0th index. So firstly we'll check whether the a4 b1 z1 key is present in the map or not. So it is not present, so we'll include it and store the corresponding string, which is that a a b a. That's all, and we have iterated over every element. So finally we'll return only the group. So final answer will be just a list which is containing this. So that's all. So if you're not clear about this logic here, you'll get a clear idea in the coding section. So let's get into the coding section. So firstly we'll get a new string array in quotes. So we'll pass the encodes into a helper function. It will be helping to find the encodes and store it in the encodes array. So we'll pass the strs and encodes, and after this we'll create a map returning string, and finally we'll return the group anagrams of strs. We'll pass the both the string arrays. That's all. So in helper function, so for store encodes, we'll get the string array 1, which is strs, and string array 2 encodes. And firstly, we'll write it over every string. So we can have an index I and write it over every element of strs array. So we'll calculate the encode of the current index by using helper function encode of strs of I. So we'll write the helper function soon. So for encode, we'll get the string as parameter, string as the argument, and actually we'll create a frequency array which will be having size 26. Why are having 26? Because in the question they have mentioned that the each string consists of lowercase letters. So we'll denote a as 0th index. 0th index will be for a, and first index for b, and so on up to 25th index, which will be for z. So we'll write it over the character array. So I will be 0. So we'll write it I over string till the final, till the we have exhausted the I mean the string's length, and we can get the character by using start character I, and we'll increment the character minus 97. Why are we doing this? So ASCII value of A is 97. We'll subtract it by 97 in order to get 0. Same goes to B. So B's ASCII character is 98. When we subtract it with 97, we'll get 1. So we are subtracting it in order to get the position of the index in frequency array. So after calculating the frequency, we'll form a string. So it should return the string, right? So after forming this, so we'll return the encode frequency. So we'll pass the frequency array, and frequency array will return a string. We'll get the frequency array. Sorry. So first we'll create a string builder. So for each frequency, so for frequency less than 26 plus plus. So if current frequency is 0, we'll continue. Else, uh, we'll take the current character. So current character will have I plus 97. So this will give us I plus 97 will give us the ASCII character corresponding to the index, and we'll typecast it to character. So we'll append the character followed by the frequency. So okay, so anyway, we'll return the string of, we'll convert the string value to string by using toString. So that's all about the encode function. So next we are going to group the anagrams. So how are we going to do it? So we'll write the function group anagrams. It will be returning list of string. So it will be having strs as parameters and encodes. We get the both the given input string array and encode string array. So there's a mistake here. So after this, we'll create a map which will be storing string and list of string. So the key will be the encode value, and the value will be the every words in given input array, that is strs, which has encoding string as corresponding key. So this is it. So we'll call this as groups, new hash map. So after this, we'll go iterate to the complete encode array. So firstly, um, we'll take the value. So list of string, let's say groups dot getter default encoded encodes of 5. If it is not present, we'll get a new linked list. So after this, we'll add the current word. So current word of the corresponding current word of the ith index. So we'll add the group dot add instead of 5. So corresponding word will be added to the group, and we'll add current encoded, there is current key if it is not present already. So encodes of I comma group. So that's it. And after this, finally we'll create an answer array. So list on stuff, new linked list. So finally we'll iterate over the each value present in the groups map. So again iterate using enhanced for loop. We'll add the group. Finally we'll return the answer. So let's check it up. Sorry. It's working fine for sample test case. Let's check with the other sample test cases. It's working fine. Let's submit it up. Yeah, accepted. And the time compressed approaches R of n. Since we iterated over the complete array, so it will be n into the longest length of a word. So let's call it any word. So space complexity will be R of n, and the approach for this problem is hashing. And that's all about this video. Thanks for watching this video. Have a great time.